All right, let's do number 6 of 1.3. I guess 0.4 is what the last part of it, but all right. We have this graph, f of x, y equals f of x, and we're supposed to draw the secant line on the interval -1 to -3 to -1. So at -3, it goes through a point just off of the x-axis, and at -1, it goes through this point. So the secant line would look something like that. Then it says draw another secant line on 0 to 2. So at 0, it's at 2, and at 2, it's 1 point something. And so that secant line would look something like that. All right. Then it says draw a tangent line at x equal -3. So right there, I got to make a tangent line. Again, that's a line that just has the same slope as the curve looks like it has right there. Touches the curve at one point. So I'd say it's something like that. And then a tangent line at x equals 0. There's a secant line, but the line would be more in keeping with the curve. It would probably be more like that. Those are just my estimates. Okay. What is the approximate value of average rate of change on this interval from -3 to 1? Well, let's figure out what these points are. So this point is -3, let's say 0.1, 0.1. This point is close to both lines there. We'll call that -1 and 1.3. And let's see, I need this one here, which is, looks like about 2.1 and up at about 1.2. Okay, and you're going to have a little different points than I'm, perhaps, because it's just an estimate. Okay, so the approximate average rate of change on -3 to -1. So from here to here, that's the blue line. So it rises from 0.1 to 1.3, which is 1.2. Over the run is from -3 to -1, and which is a +2. So I'm getting about 0.6. From 0 to 2, it goes from, wait a minute, oh, that's up here. Goes from about, oh, that's 2.3. Ooh, 2.3. 2.3. So this should have been 2.2, so I get 1.1. I'm already making mistakes. Okay, 2.3. Okay, from here to there, it's going from 2.3 to 1.2, which is down 1.1 over, it goes from -1 to 2.1, which is 3.1. That one is approximately, where's my calculator? 1.1 divided by 3.1, it's approximately 0.3. Oh, and that's down, so that was negative 1.1. Oh, I'm making a lot of mistakes here this morning. Down about 0.35. Okay. Okay, what's the approximate value of the instantaneous rate of change at -3? Well, that would be slope of the red line. Now we have the -3.1. We need to find another spot on this line. Let's see, that looks like a line right there, which is 3, and it hits it right, there's -2, which hits it, so it looks like it hits it at about -1.9, -1.9, and 3. Again, I'm just picking a point. I could have picked a point down here, and then I'm going to use the one on here. I could have used a point here and there. But anyway, so the change in y goes from 0.1 to 3, which is 2.9. That's the rise. Over the run, -3 to -1.9 is 1.1, which is approximately 2.6. You do the slope there. And now we have to do it for this red line, which we have this point, 0. This point is 0, looks like about 2. We have to find another point. I'm going to use this one, which looks like about 3.2, 0. So it fell 2 over a run of 3.2. So I get the instantaneous slope right there. My rough estimate is -2 divided by -0.63. Okay? This line is a little steeper in the negative direction than the blue line was. Okay, that's all they want to do. How are these values related to your work in A? So this is the slope right at that point, whereas on the average from here to there, the slope gets less because the curve is starting to go up. And here, this is steeper than this one because the curve starts going down.